What we're going to do today is we're going to look at the relationship between an exponential equation and a logarithmic equation. When we're looking at this, what we notice is that b, our base value, is the same b for the base value for the logarithm. We also notice that our exponent is by itself, and whatever it's equal to is actually our log. So when we're looking at our first example, when we rewrite this in a logarithm, what we're going to do is we're going to put log, and then our base number is 2, so we're going to do log base 2 of 16 equals 4. So letter B is going to be the same, even though it's a fraction. We're going to do log, our base number is always underneath the exponent, 2/7 of y is equal to x. Now, once again, the point of a logarithm is to get the exponent by itself. So notice that the x is by itself. So looking at letter C, we do log base 4/5 of b is equal to a. Now for example 2, what we're going to do is we're going to do the converse. This time, what we're going to do is we're going to write an exponential equation. So our base number is 5, so we're going to put a 5. Remember, the exponent is always by itself in a logarithmic equation, so 5 squared equals 25. And we know it's true because 5 squared is 25. Now, natural log, remember, is log base e. So when we're rewriting it, what we're going to do is we're going to put the base is an e, our exponent is the value by itself, and we put a. With fractions, we do this exact same thing. Our base number is 1/2. We could put it in parentheses, we don't have to. -3 equals 8. So that's how we convert it into an exponential equation. Now what we're going to do is we're going to solve. When we're solving it, what we're going to do is we're going to write it in terms of exponents. And then once we write in terms of exponents, we're going to do what we did in the last unit. We're going to actually solve it. So looking at the first one, we have 2 as our base. Our exponent is x. It's equal to 32. Now, if you remember from a while ago, in order to solve an exponential equation, we need a common base. So this would be 2 to the x equals 2 to the 5th, because 2 to the 5th is 32. Remember, we have common bases, they cancel. So x is equal to 5. So looking at the next one, we're going to do the same thing. Our base number is 3. Our exponent is x, and it's 1/27. What we need is a common base. So that would be 3 to the x equals 3. Since the 27 is in the denominator, we're going to flip it. So this becomes -3. Bases are the same, so they cancel. X is equal to -3. For letter C, we do the same thing. Our base is 4. Our exponent is x plus 3, and then it's equal to 8. Just like the other two examples, what we need is a common base. Our common base is going to be 2. So we're going to go 2 squared. And then we put x plus 3 is equal to 8. Just like the other examples, we need a common base. So we have 2 to the 2x plus 6 is equal to 2 to the 3. Bases cancel. We get 2x is equal to, I'm going to subtract the 6, and I get negative 3. So when I divide it by 2, x is equal to negative 3/2. Let's look at a few more examples. Looking at letter D, our base is 5. Raising it to the x is equal to 125. So that would be 5 to the x equals 5 to the third. Bases cancel. X is equal to 3. Looking at letter E, our base is 1/2. We're raising it to the x equal to 16. This one's a little tricky because we need a base of 2. So the 1/2 becomes a negative. 16 becomes a 4. We have a common base. They cancel. Since that's negative x and this is positive 4, our answer is x equals negative 4. Looking at letter F, our base number is 27. We're raising it to the x minus 1, and that's equal to 9. What we need is a common base. Our common base is 3, so that would be 3 to the third gives us 27. And 9 is 3 squared. 3's cancel. We get 3x minus 3 equals 2. So what I'm going to do next is I'm going to add the 3. I get 3x equals 5. I divide it by 3, so x is equal to 5/3.